This is video 2 of my final for game 370. In this video I'm going to be talking about the skybox, the terrain, and then we'll see how far we get. Okay, so first off, the skybox, as we can see, it is set up like a specialized graphics object. It stores a pointer to its shader. I just use the shader texture because, as you said in your checklist, we don't really need to have the skybox be affected by lights. We don't really want spotlights in the distant mountains. And then it stores the text, or a pointer to the texture, as well as a pointer to the model of the skybox, which is just the inside-out box. Now moving over to the actual Skybox Generation, here we see the actual Skybox Generation. It's literally just an inside-out box. The only specialized thing here was the UVs for my Skybox. The UVs were not quite at a third. They were a little skewed, so I had to kind of play around a little bit, and yeah, so this is what I've come up with. I did include actually UVs in here, but without lighting affecting it. Obviously, those don't matter. Not UVs. I'm sorry, normals. I'm confusing myself here. And then obviously at the end of the generation it sends its verts and its triangle list to the model to be generated and sent back to it. Obviously in the destructor it controls its own skybox. However, it does not control the shader or the texture, and therefore it does not delete it, as those are deleted in the DX app, which I should probably show you the deletion and show you that everything is being taken care of. Here are all of the deletion functions for the shader, the graphics objects, models, textures, terrain and skybox, release and delete. Now, just to be super careful, since it exited, there's no memory leaks. Anyway, there's no memory leaks. You can check it when you build it yourself. So that's not really important for me to show. So let's move on to the terrain. Here we have the terrain. Now this has a couple private methods for the texel index and the vertex index. I just said vert index because I was getting really tired of reading vertex index because it's just too much. So the terrain actually has a shader for the texture that takes in multiple lights. It has a pointer for the terrain texture, and this is a pointer as well to the shader. Pointer to its model. It also has vectors for ambient, diffuse, and specular. It also has the settings for ambient, diffuse, and specular, much like a graphics object would. It has a return function just to get the model. It also has a render function. Same with the skybox. The skybox in the .cpp has this render, which is exactly the same as my graphics object texture. So, turning over to the .cpp, we can see that here are my two private methods. Obviously, not very complicated. And then here's the actual generation of the terrain. What was interesting about this is I actually copied the code that I did for Game Engine last year and then ended up deleting all of it because I redid it a different way. Because you obviously most likely do not remember this, but I put them in backwards, put the triangles in backwards, and then I had to reverse them again to make it actually come back upright. It was a whole mess. But that code was messy. But this is an improvement. So we obviously have the repeat, the U, and the repeat V, and then we go through and create the verts based off of the height map pixels divided by 255 times the max height. plus the Y translation, so we can do like -10, that kind of thing. For instance, to move the terrain down further, the Z point and the X point, and this is all done on a basis from 0. So when we get the actual length, they start off at half, -half, whatever the length is, both X and Z. So in my case, for my demo, it's -500. They start off, which obviously you probably have seen the demo in the video prior. I'm not showing the entire terrain, but that is the terrain that I've used. Speaking of, it just finished uploading. The triangles, obviously, being added in right there. And then we go down here and we do the normals. This was a little more challenging than the actual generation. It takes the average of every face that the point could be facing, which the maximum is 6, I think, if it's like right in the middle of the terrain, if it's one of those middle points. And then it calculates the average of the number of normals that it actually faces. Yeah. It adds the normals, obviously, to I use a vector of vects, and adds the normal to that vector, and then adds the number of faces up. And then it creates the model from the vertices and the triangles. Obviously, the deletion, it only deletes the model, as that's the only thing that it actually owns. The ambient, diffuse, and specular are all not pointers, so it doesn't have to deal with that. And then we come down to the actual render, which, as you will see, is virtually identical to my graphics object with multi-light. In fact, I originally had this just send the model to the graphics object multi-light, but then I read in the checklist that you wanted a separate graphics object, so that's why I created a render function in this. So let's go ahead and look at some graphics objects. Actually, I think no. Let's look at the graphics objects very quickly, because the shaders will be a whole nother video and a whole nother length of time. So let's just look at the ones that take in the multiple lights, as this is the most advanced version and basically takes everything from the other versions and just adds to it. And all it really adds to it is the multiple lights portion. Everything else is the same. So as we can see, we've got a few methods here: set world, set texture, set textures. So this one just takes in the texture, it sets it for all. We can see that right here. This one takes it in for a specific mesh number, makes sure that that is a valid mesh number, and then sets the texture. And then this one is the one which I use in my dxapp.cpp that takes in the array of texture pointers and the number that there are, and then assigns. And obviously making sure that it didn't give me more textures than I actually have in the model. Set world. Set ambient, so this sets the ambient light. For all meshes, I have a list, or an array, I should say, of vectors for the ambient, diffuse, and specular, so that I can have them for multiple meshes. Obviously, this has two methods. One is it just takes it in, sets it for all. One is it takes it in for a specific mesh number, and we can see both on the right here. Diffuse is the same way. Specular, same way. Now the render, we bind the vertex index, or the vertex index buffers. Say that 5 times fast. And then we go and run through all the meshes with the shader. We don't do this in the terrain because the terrain obviously only has one mesh. Yeah. And then here we are actually setting all the values. Obviously pretty standard. I use the default values that I have for ambient, diffuse, and specular are all 0.5. I actually use these in my scene, and I think that they work rather well. Yeah. I think if somebody didn't want to go in and actually set them themselves, then those are good settings. Obviously, there's a bit of personal choice in there, but yeah. So now we're going to look at the color light. So the last one took in texture. This one just takes in color. Obviously, very similar. The only difference is that we set the color instead of the actual, instead of the texture. Over here, you can see these all the same. I did originally have a list for the mesh colors, but then I replaced that with just the ambient list since it's basically just the ambient color. It has a pointer to the shader and the matrix for the world, and that's this is the same as in the textured object. Obviously on the right we can see everything is the same. Set color with just the color takes it in, sets it for all of the meshes. Set color with the specific mesh number takes it in, sets it for the specific mesh number, the ambient and the diffuse. So then they can go in and set the ambient and set the diffuse if they want, and the specular by themselves. Here we just send it all in. Yeah, pretty basic render function. Obviously it's a lot less complicated than the texture one because we don't have to deal with the texture. Now setting the default values. Yeah. Okay, so that's my video 2. I covered the terrain model, the skybox, my 2 very large graphics objects. I could go into the regular one. In fact, I will very quickly. But the only difference is that there's no light. And yeah, that's pretty much it. Whereas in the multi-light, we can see there's lights that we take in, and we set the diffuse and specular because most of the stuff is in the shader. So that's video 2, and I will upload this and record video 3.